Hey everyone, I'm Captain Jack. Welcome back to the School of Applied Energistics 2. In March of 2015, over 7 years ago, we released a 4-part AE2 video series that collectively became our most watched series to date. Clocking in at over 2.2 million views, thousands of modded Minecraft players have relied on our series to give them all the knowledge needed to construct an intricate and efficient AE2 network. Now, in 2023, we've redone the entire series and included all the newest blocks and changes, so the next generation of Minecraft players have a current source of information to rely on. The new series is longer and contains even more detailed explanations of nearly every item in AE2, with real in-game applications included in each video to better teach you the mod. In episode 1, we'll be showing you how to set up your very first network. In episode 2, we'll be covering a massive range of blocks and items too numerous to mention here. This is the longest video by far, clocking in at over 40 minutes. While this may be too much for most people to digest in a single setting, I had trouble finding a reasonable spot to split the video, so for your convenience we've added timestamps in the description below so that you can easily jump to any part of the video that you need to. This will be true for each episode. In episode 3, we'll cover auto-crafting. Episode 4, which is a little more recent, recorded 4 years ago on a different version of Minecraft, will make a reappearance in this series because the content really didn't change enough to warrant a whole new video. Here, you'll learn all about advanced networking and P2P tunnels, which are some of the most complex multiparts in AE2. Finally, in episode 5, we'll cover spatial storage. These videos are recorded on all the Mod 7, Minecraft version 1.18, but since so much changes for the early game in 1.19, I've included another video which explains the new Certus growth process and the automation of it. The link is in the description below. This series is a culmination of well over 50 hours worth of work between setup, recording, and editing, and we hope you appreciate the outcome. Enjoy the series. If you ever wanted to build a giant factory that does literally everything for you, you've come to the right place. In this episode, we're going to be talking about AE2 auto-crafting, and by the end of it, you'll be a pro. To start delving into the world of auto-crafting, these are the blocks that we're going to need. There are 5 different types of crafting storage, ranging from 1K all the way to 256K. There's the plain blank crafting unit, that's just a filler block. Here we have the ME pattern provider in block form and multi-part form. Next, we have the molecular assembler. And then finally, the ME pattern encoding terminal, which will take blank patterns, and the ME pattern access terminal. In front of me is an example of a very basic minimalistic auto crafting network setup. So we're going to start here by going right to left and then go back left to right. The crafting storage can either be placed as one single block or a multi-block, and we'll talk about multi-blocks in a little bit, but you can click on these things and see crafting statuses inside of the block itself. Next, we have the ME pattern provider, and if you click on this, it has a spot to put patterns in here and return inventory here. Usually nothing stays in the return inventory very long because it just gets sucked right back out into the system. The molecular assembler can best be described as just literally a crafting table. If you click on this, you can see inside here there's a 3x3 grid, there's some spots for acceleration cards to make the craft go faster, and there's a spot for a crafting pattern in here, which again we'll talk about in a little bit. And a simple way to view this setup is think of the ME pattern provider as a player and this molecular assembler as a crafting table, and this knows how to build a pattern and it just builds it in here automatically and then gets sucked back out into the system. Now, how do we teach the pattern provider to make a pattern inside the assembler? Simple, in the ME pattern encoding terminal. In this video, we're going to be talking about shapeless crafting patterns first, that's this first tab, processing patterns next, and then smithing and stone cutting patterns at the end, which won't take very long at all. Now, all you really have to do here is teach your system how to make a pattern and then encode it on a blank pattern. So in this case, we want to teach the system how to make oak planks. So you can take one oak log, place it here, and it will automatically know the pattern. Now, when you go over here, you want to put your blank patterns in this slot. You can fit up to 64. And when you click encode pattern, it's going to copy this pattern down here, and you can pull it out and put it on your hotbar. And in the mouse over, you'll see that it crafts 4 oak planks with 1 oak log, and it does not allow for substitutions. Once you have the crafting pattern in your hand, if you just hold shift, it will tell you what the crafting pattern has encoded in as a recipe. Next, you're going to open up your pattern provider, shift click or click and drag your pattern into the pattern spot up here. And just note that each pattern provider has a spot for 9 different patterns. Now, this pattern provider knows how to make oak planks, and it's going to make them inside of here. This pattern provider has the ability to push and pull items. So it's going to take the log from your system, push it into the molecular assembler, and then pull the 4 planks out and back in. Now, if you open up your crafting terminal, you're going to see that oak planks are now craftable. So if we click this and hit 1, it can't just make 1 oak plank because each log equals 4. So when I click 1, it's going to equal 4. This will cause a little bit of headache a little bit later on, and don't worry, we'll cover that. But for now, I'm just going to craft 1 plank and hit start. And you're going to see that it's crafting right there. You see that nice little animation that you have, and now we can pull 4 oak planks out of a system. You can also see that there's a little plus up here, and that means that if you have oak planks or anything that's craftable stored in your system, you can tell that it's craftable by looking at this right here. A couple more things about the pattern provider is when you place it down, it will recognize adjacent blocks. So for instance, this one here is connected to a molecular assembler. So when you look inside of this pattern access terminal, which we'll go into in a minute, you'll be able to tell that this one's connected to the molecular assembler. And this one, for instance, is connected to nothing because technically this is not a valid inventory. So this is just going to say nothing in the system. The pattern access terminal will show you all of your pattern providers on your entire network. And you can see here that this one is named molecular assembler, like I just said, and that's this one right here. This one being named nothing is that one on the end there. Now what's really cool about these pattern terminals is you can take these patterns and move them anywhere on your entire network, even hundreds of blocks away in this terminal right here. So right now I have this pattern that makes oak planks in my molecular assembler pattern provider right there, and I can take that out and just put it in this one down here, and it will disappear from here and go right into here. So you can easily move patterns around on your entire network with the pattern terminal here. You also have some really cool options up here in the pattern terminal with display mode that shows visible pattern providers with empty slots, and all pattern providers. Honestly, this one that shows only empty slot pattern providers is a really good one because eventually when you have so many recipes, you don't want to scroll through this giant list. If you can make the ones disappear that are full, that makes it easier to find the ones that you can fit more patterns in. So this is a really awesome feature. All right, now let's make our craft a little bit more complex. Now we know how to make oak planks, so let's make some sticks too. So we're going to put a couple things in here, and it doesn't matter where it is in the grid. So I'm going to pattern and code this. And then I'm just going to click these to clear them out. And then I'm going to make a fence using sticks and planks. Okay, and you can see that it knows, again, with the plus here, it knows how to make these items. And it doesn't know how to make the sticks yet because we haven't put this crafting pattern inside the pattern provider. So let's go ahead and shift click in these here. And now our system knows how to make a fence. Now I'm going to go ahead and craft a fence. And let's say we'll do 100 of them because I have the materials, and hit start. Okay. Now what's going to happen is you can see that inside the molecular assembler, it's going to craft all the planks that we need, and it's going to craft all the sticks, and then it's finally going to craft the fence. And this is going to take a while because we only have one of these, which we'll improve on in a second. But you can also see what's going on in a couple different places here. If you click on your 1K crafting storage or whatever tier that you have, it will tell you approximately how long the craft is going on, and it will tell you what is happening. So the yellow is the scheduled items, and the green is what's currently being crafted. So we're scheduled for 102 fences and some sticks, but right now it's using oak logs to make all the necessary oak planks. And you can see here that our time is slowly ticking down. If you decide that you don't want to make 100 fences and you made a mistake, you can open up your crafting storage, hit cancel, and it will stop the craft. If you're looking inside a crafting terminal, there's a little button up here called crafting status, and it's a little bit difficult to get to in this mod pack, but if you click this, it will tell you all your available crafting CPUs. It will give you a status bar here, and it will show you the same thing as if you were to click on that individual block over there. So this is a little bit better of a way to see what the crafting status is on your network. Inside the ME pattern encoding terminal, we also have the options to enable substitutions and do fluid substitutions. Now, substitutions are disabled by default, but honestly, I would just recommend turning them on unless you have a good reason not to. And that will allow you to say, let's say if you only had 3 oak planks in your system and you wanted to craft a crafting grid, but you had one more of a different type of oak plank, it would still recognize that this was a usable block in your pattern, and it would just go ahead and pull literally any plank whatsoever to make your crafting table. So that's really useful. Now there's another really awesome button here called fluid substitutions, and this is amazing. As long as you have fluid storage inside of your system, you can go ahead and put, like, let's say a bucket of creosote oil and program your system how to make treated wood planks. And if you have this checked off, you can see that when you mouse over it, it highlights the bucket of fluid in green there. And this is going to try to substitute a bucket for actual fluid that you have stored inside of your system. So if I clear this out, you see I have no buckets at all inside of my system, but I have oak planks, which are craftable, and I have 5 buckets of creosote oil. I can go ahead and click this, and it has all the materials needed to make treated wood planks, and it's going to use, see it already ticked down to 3 buckets, it's going to use this inside of your system to craft treated wood planks. And there you go, I have 8, 16. This is an amazing button. Now the information that we just covered is going to carry us through for the entire rest of the episode. We did cover a lot in this one little space here, but we got a lot more to go. So now that we are oiled up and ready to go, let's go ahead and turn up the awesome. Now we're going to level up our crafting system by adding a few more molecular assemblers on our pattern provider and going over what happens inside of these crafting storages and why you need better tiers of them. The first upgrade we'll do is we'll add a crafting monitor on top of our crafting storage here. Now, the crafting storage, which we haven't talked about yet, is a multi-block, which I can add more around it. But if you add more while there's a craft going on, it's going to break the craft and you're going to cause problems. Inside of here, you can click on it just like you can click on this, but this just gives you the convenience of being able to see what's being crafted right on here. Here you can see that despite adding multiple molecular assemblers on our pattern provider, it's flashing in and out of each one. And this is really impractical because we do not have any co-processors on our CPU over here. So we'll add those in a little bit. The takeaway from this here is going to be to see how many bytes we're using per craft. So let's say I want to craft 200 oak fences and I only have a 1K storage block available. It's going to say that I'm using 987 bytes for this specific craft. And I can go ahead and start that and everything's going to work fine. It's going to gear up and it's going to go. Let's go ahead and do a craft that takes more than the amount of storage that we have, which is 1K right now. So let's do 300. Now it's going to say that the crafting plan is going to need 1410 bytes, and it's not going to allow me to start. It says there's no crafting CPUs available because I just don't have enough bytes on my CPU. So I'm going to walk over here to my CPU. I'm going to click, 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 and provided that the multi-block structure is a rectangle, it will form the multi-block. Here you can see that it's broken, fixed. Okay, so now I have a really big crafting storage, so now I should be able to craft my 400 fences. Before I forget, the crafting CPUs, which is what I'm calling this collection of individual blocks forming a multi-block, only uses one channel no matter how many blocks are on it, which is really fantastic. Now what we want to do is we want to have the pattern provider utilize different molecular assemblers attached to its face all simultaneously to improve our crafting speed. So before we're able to use all the molecular assemblers, we're going to have to add coprocessors to our CPU. So I'm just going to add 2 of them here on top like this. Now, since the pattern provider can already always use 1 molecular assembler chamber, the extra 2 coprocessing units are going to allow access to this one and this one. Now, in any multi-block CPU, you really don't need more than 5 coprocessing units because the pattern provider, like I just said, already uses 1 molecular assembler chamber facing, and the other 5 just allows access to the other 5 sides of the square, meaning that 5 is the max. Now when we go ahead and craft our 400 fences, you can see that it's making planks here, sticks here, and forming the fence here. So it's making the patterns much faster because it's having different crafting operations happen in each of the different assembler chambers. Now we're going to expand our crafting network. As your network gets more luscious and complex, you are definitely going to need multiple crafting CPUs because you're probably going to want to queue up multiple crafts simultaneously, and you're not going to be able to do that if you just have 1 CPU. Now we have this big giant CPU, which I've named Big Bertha as a throwback to the original crafting series, and over here we have this little stupid one called Aim Derpson, and I've attached an ugly brown cable to it because it sucks. Once you have more than 1 CPU on your system, you can go inside your crafting terminal, Click on this up here. I'm sorry it's difficult to see. And then you can see the available crafting CPUs. So here we have AIM Derpson. He's only a 1K little guy. And we have Big Bertha, which has 361K available, and 5 coprocessors up here. So Big Bertha is going to be selected for the big jobs. So let's get a craft going, and let's do it faster and more efficiently than we did previously. Right here I have the pattern to make dense smart cable, and I have all the different tiers, and I have all the materials needed. So what I'm going to do is I'm going to insert all these patterns inside of this chamber right here, which you can see there's 7 channel-wise. There's 7 pattern providers here. Each has a couple molecular assembler chambers, 3 to be exact, that they have access to. So let's go ahead and put these patterns in here. One common mistake before we do this is that you might want to jam all the patterns inside of one pattern provider, and that will definitely be a mistake because you want to have more things happening simultaneously. And the better that you can spread out your patterns, the faster your craft is going to be. So you might accidentally gimp yourself by putting too many of the same type of, let's say, mod inside of pattern providers that are too close to each other, and you may slow down your crafts inadvertently. So what I'll do is I'll open up my pattern access terminal, and you can see that I have 7 molecular assemblers. That's those right there. And I'm going to insert these patterns like this. If I insert them all in a horizontal line, they're all going to go in the same one. So let's spread these out just a little bit better, actually. There we go. Okay. So now if I open up these, you're going to see that there's different patterns, and one of them will be empty, a couple will be empty, that one's empty. There's different patterns in different places. That means that whatever patterns in here has access to these 3, and whatever patterns in here has access to these 4. And if you want to really be technical, you want your dense cable inside of the center one because it has more available molecular assembler chambers to use when it's putting together its craft. So now I'm going to queue up a craft. I'm going to hit my dense cable. I don't want to make anything else below it. These have options to craft, but I don't need those. And I'm going to make 100 of these and hit next. Now, I can choose which crafting CPU I want to use, and it's going to tell me how much is available for each. So Big Bertha has plenty of space to make this, but nobody else does. So it doesn't even show AIM Derpson on here because he's too tiny. So we're going to go ahead and start this up, and you're going to see that flashing inside of here is all of my recipes, and you can see how much faster this is happening because it's spread out over a larger area, and each pattern provider is making different stuff all around here. So, really cool. And here's what the advanced craft looks like. It's showing you the countdown. It's still got a lot of covered cable to go, but this is a really great way to make multiple tier recipes without having to put the recipes individually in there inside of your crafting grid. It's the whole point of this video. Well, real quick before I forget, the crafting units, which essentially do nothing, can be used to fill and multi-block structure if, let's say, you don't have enough coprocessors or crafting storages to make the entire block. It's just a cheaper solution to make a bigger box. Now you might be asking at this point, but Captain, how did you name your crafting CPUs? If you right click on a Quartz cutting knife, Nether or Certus is fine, put an iron ingot right inside here, put a name in here, you'll get an inscriber name press. Go ahead and open up an inscriber, put your name press inside of here, and you can use 2 if you want, so you can do Mad Chamois, MK2 down here, and then put a block inside of here. It's going to work, and it's going to name this ME pattern provider something different. Mad Chamois, MK2. For the crafting CPUs, I actually named the crafting monitors in both cases, but I believe you can name any block inside of the multi-block and it will recognize the nameplate. This is a fantastic way to recognize these pattern providers when they are completely surrounded by molecular assemblers. So in order to get the juiciest, maximumist performance from your pattern providers, you're going to want to surround them with 6 molecular assemblers. That's going to allow 6 simultaneous crafts by 1 pattern provider, which is really great, but it also creates a problem because now you can't get into the pattern provider. Now we already know how to access these remotely via our panel over there. The problem is when you have multiple pattern providers surrounded by multiple molecular assemblers, and you get confused as to which one is which. In this case, I've named the first one locked up, the second one locked up again, and if I go here into my terminal, you can see that I still have access to these, and I can put patterns inside of them, and I can initiate a craft. If I still have enough stuff left, and I do, okay? And these are going to be put to use, and you can see that there's multiple things going on inside of here, which is really great. Crafts happening super fast, and I have access to these pattern providers. Now, as you progress later and later into the game, you're going to get more and more patterns, and you're going to find out that you actually need a lot of pattern providers. So you might want to craft a big, chunky boy like the one behind me. Now, this is not an example of maximum efficiency speed-wise, but it is pretty space efficient, and it's really easy to connect to your controller. So basically you see that I just have some dense cable slapped onto the bottom of here, and each molecular assembler can transmit 8 channels itself. So if you just put dense cable on the bottom of a giant row like this, or you can make it a square, whatever you want, the channels are going to automatically find their way all the way up to the top. You can see everything's online, and I have these 2 big crafting terminals here. So lots of pattern space. Yeah, you're going to need this. Here's an example of, let's say, maximum speed efficiency, where I have 6 molecular assembler chambers on all sides of my pattern providers. This is going to allow for the maximal crafting capabilities, but you can see this is going to start taking up space a lot faster. Now, at this point, you might be saying, hey, Captain, I can take these pattern providers and make them multi-parts, and I can fit so many into a little space. Well, you might be right, but you'd be doing it wrong. Because if you attach pattern providers like this in multi-part form to molecular assemblers, yes, you'll still be able to do the crafts, but basically you'll negate all of your co-processing units, and it will craft much slower because each of your recipes, and there may be 9 per, may only be able to do 1 craft at a time inside of each of these. So while this maybe would work for you somehow, definitely do not recommend. Now, I just mentioned that molecular assemblers can transmit up to 8 channels, but they do not use any channels on their own. In fact, they can be used to craft individual items on their own. Now, you can't queue up multiple outputs through one crafting grid, but when this one is done, you can take it out and it will craft another one. You can attach a lot of acceleration cards, like I said before in here, but you can actually put a single pattern inside of the block itself, which will know how to craft one single thing. Again, I haven't really found this very useful in most circumstances, but in this instance, I'm using this to craft cobblestone 5x, and if I go ahead and take this out, what these do is they daisy chain together. So if the craft finishes here, it pushes to here, pushes to here, pushes to here, and so on and so forth. And you can kind of see that happening where it's making compressed cobblestone. So this is an interesting usage for this. You could daisy chain some of these together to craft something that you always need a lot of, and then maybe slap a storage bus onto the final stage of it, so that let's say maybe you want a really advanced craft and you want one big solar panel always available in case you need it, but you don't want your system to be backing up with too many of them. You can slap a storage bus onto the last one here and then pull it out of your system when you need it, and then it will automatically make another one for you. Again, not sure how useful this is, but do whatever you want to do. All right, now we're moving beyond shapeless crafting and into processing patterns. So you can see that these GUIs are a little bit different, and we got some more stuff going on here. So in this example, I'm going to craft blaze powder from blaze rods. Now, for some recipes, it's really important to have the exact recipe encoded properly. It's not important for all, but let's just say, for the sake of your sanity, just make sure you do this exactly right every time. That way you don't have to go backwards and try to diagnose a problem where you don't know that you caused one. So a pulverizer is going to turn 1 blaze rod into 2 blaze powder. And let's see if that happens all the time. 3. Okay, so it can either make 2 or 3, but at minimum, it's definitely going to make 2. So in the processing patterns tab here, I'm going to take 1 blaze rod and say that it equals 2 blaze powder over here. Now, you have to put the actual main output in the top here, the one with the little hammer. If you have secondary outputs, you can put them here. Wouldn't really recommend it. There's some cases where you might want to do that. You'll encounter those and you'll be able to figure those out after you're done with this video. But for now, we're going to say 1 blaze rod equals 2 blaze powder. We're going to hit encode. And then we're going to go ahead and put it in this pattern provider here, which I'm now using multi-parts, but we're not going to put it in there by hand because we're not noobs. We're going to go ahead and take our pattern, shift clicking here, and put it right in the pulverizer, and that's going to be named the pulverizer because this recognizes the block that it's facing. Okay, now our system knows how to use 1 blaze rod, provided we have enough in our system, which now we do, to craft some blaze powder. And I'm going to go ahead and craft 2 blaze powder, hit start, and it's going to take those, put them in here. You see the machine lit up. There's my 2 blaze powder. I got 3, but that's okay. It's going to pull it back into the system, and the craft is done. If you want to re-encode your pattern, whatever it is, processing shapeless, and there's already a pattern inside of it, like this one is, you can go ahead and shift right click, and it will just make it a blank pattern again, and then you can go ahead, and throw it back inside of here. Now, so you can see what not to do and why it's important to have exact recipes, I'm going to say that 1 blaze rod equals 4 blaze powder. Go ahead and encode that and put it into my, if I can find it here, 1 equals 4, right here, okay? So now if I go ahead and craft my 4 blaze, because that's what my recipe says, because that's what I made it say, it's going to try, just like it always did, and take 1 blaze rod, squish it down into its various parts, but I only got 3 instead of what I wanted, which was 4. So inside of here, I'm stuck. It's waiting for this last blaze powder, and it's going to be waiting indefinitely. And if I go up here, you can see that the progress does not go anywhere and it's stuck. And if I want to do a new craft and make, let's say, 1 more, I can't because there's no CPUs and it says there's missing ingredients and your recipe is broken. Now, there are literally hundreds of different machines that you can set up pattern providers to. Just make sure that on the machines that you configure your input and output settings properly so that your pattern provider can push or pull, whatever the case is. And you make sure the stuff gets imported back into the system so that it recognizes that the craft is finished. Because once the items get back in, that's when the craft recognizes it as being done. As a last resort, if you really need to, if your crafting pattern is stuck like this, and you just go ahead and put manually the item that's missing back into the system, the craft will finish itself. Okay, now we're going to do something a little bit creative with a pattern provider, in that we're going to attach one to a chest and just dump a bunch of items into a chest with the expectation that we're going to get a processing pattern back into our system through some other means. Now, this is where things start getting real juicy, so listen up. We're going to go ahead and make some living wood with Botania, a mod that I abhor, and we have a pattern process in here set to make living wood logs. So let's go ahead and look in here. This is going to produce 4 living wood logs with 4 oak logs. Now, how on earth is this going to happen? Well, don't worry, I will show you. Let's go ahead and queue up a craft with 4 of these, and I will show you the process. So, all of my logs, and there they are going to get dumped inside of this chest. Then they're going to get sucked out of the chest into a sub-network over here and pushed out through formation planes that are underneath the logs. Then my annihilation planes, which are set up with a storage bus here to only accept living wood, are going to break the living wood when it changes because of pure daisies surrounding them. The 4 wood logs are going to go back into an interface that's attached to my system, and the craft is going to say that it's complete, and this is how you automate all sorts of other stuff. And again, this was like the most straightforward example that I could think of, but this could be used for so many other things where you want to just send something to a different area of your base or even into a different mod. You can send stuff to refined storage to make if you want to, really. As long as it gets sucked back into your system as the product that you set the output as in the processing pattern, then you're going to have no problem, and you can auto craft more than you ever thought possible. And there we go. Our living wood logs are done. They get broken by the annihilation planes, sucked back into our system, and the craft is done. Yay! Now, the pattern provider doesn't necessarily need to be a multi-part facing a chest. You can use it just like this, but another great use of this sort of setup is a way to make fluix dust automatically, just like this. I program the recipe. The items go into the chest, drop down through the formation plane. They fall into the water, turn into fluix dust, and get sucked back into my system. And if I click here, you can see that it's slowly crafting my fluix dust. Perfect. Crafting CPUs can be really, really big, but I didn't want to risk breaking my tutorial world, so I left the last corner of that block undone, but you can make these like 16 by 16, and this is too big. Here we have another example of how to use a pattern provider just in the regular block form instead of multi-part. So here I have 3 metallurgic infusers surrounded by 1 pattern provider, and the pattern provider only has 1 pattern in it, and it says you can make 1 infused alloy with 1 iron ingot. But before I fail to mention, one of the most useful features in very specific circumstances for these pattern providers is blocking mode. And blocking mode is not going to put a new pattern's ingredients into the surrounding block before the current one is done crafting. So this prevents, let's say if I queue up 64 of these, it prevents all 64 iron ingots to going into the machine at one time. Instead, it will just put 1 in there at a time. So to see that happening, I'm just going to go ahead and craft 10 of these things right here, okay? And you can see that my machines are whirring up, and there's only 1 ingot in here at a time. So once this one's done, it pushes the next one, and the next one, and the next one. And you can see that if I turn blocking mode off, it's going to start jamming a whole ton of iron ingots inside of the metallurgic infuser. One of the advantages of using the regular block is that if you have multiple machines capable of crafting the same recipe, once one of them gets full of items, it's going to start pushing them to the next available machine, and you're going to actually be able to make things even faster. So I queued up about 200 of these things, and now you can obviously fit only one stack per machine in here. So, you know, once I fill up this machine, it's actually going to start filling up this machine. So it's going to make your item even faster than it would if you just had one pattern provider slapped onto one machine. This setup is also using the input-output feature of the pattern providers. So I actually have these metallurgic infusers set up to input and output. So the recipe, the iron is actually going in and back out. So it's saving me actually an import bus on this setup, which is really cool. This technically isn't auto crafting, but it's another way to set up your system that I'll just kind of mention as a bonus here. Inside of this metallurgic infuser, let's say I want to constantly push iron ingots inside of here and redstone to have a stock of 64 in this machine, but I want to have access to this 64. I don't want it to continually make the alloy. What I did was I attached a storage bus on the machine as an output, and then if I attach this to the system, it's going to recognize that there's 64 in there. And what I can do is whenever I need infused alloy, I can, let's say, take half of these things out, and then once the machine has space to continue functioning, it's going to keep making them. It's going to build back up to 64 and make no more than that, but I'll always have access to a stack of them in the system. So just kind of a different way to set up a craft. All right, now as promised in an earlier episode, we'll be talking about the crafting card now. If you mouse over the card, you can see that it can be used in an interface, a level emitter, and an export bus. So first, we're going to talk about the export bus. So when you put in the crafting card over here, you get a little button over here that says crafting behavior, and you can use one of two modes. You can use stocked items or craft while exporting, so it's basically either or you can say do not use stocked items, only craft when exporting. This is definitely the better option here. Using stocked items has the chance to basically liquidate a whole bunch of whatever you're trying to export in the system. So again, it's gonna depend situationally what you're using this for. But usually you don't want to use stocked items. So this export bus is set to export oak planks into this chest. And what it's doing is it's basically we have the pattern over here, right? So you need, in order to use the crafting card, you need to have the pattern that it can make attached to a molecular assembler somewhere else or a machine, right? You can't just say, oh, I'm going to stick a crafting card in here, have no CPU, have no assemblers, no pattern providers, and expect this thing to craft. It's not going to work. This is supported by this setup over here. So the system knows how to create oak planks, right, out of one log. So my bonsai tree is growing, and every time that it grows and I cut it down and I get a log from it, the log is going to automatically be split into planks because this export bus is being set to export and craft all the time. So provided that there's room inside of my inventory, every time I get a log, it's going to automatically get crafted in there and thrown inside of my chest. So another way to use a crafting card is inside an ME interface. And what the interface will do is it will keep a certain amount of stocked items and craft those stocked items inside the interface for your access all the time. So let's say I want to have 10 furnaces stocked at all times. It's going to know how to craft the furnaces because I have them programmed in here. You can see that it's making them right here, okay? And it's slowly filling up. So this is saying I want 10 furnaces at all times. And this is similar to the alloy setup that I just showed you. But basically what the storage bus does is it allows access to the contents of the interface. So let's say you're always like throwing away your iron shears, which for some reason I am all the time. I hate making shears. I don't know why. It's inconvenient, even though it's so easy. So my interface is set to stock one shear at all times. So if I take this one out and let's say it runs out or I throw it out in the system, my system is going to automatically know how to craft shears, and it's going to keep it stocked inside of here, and it just made another one. So I'm going to have one shears inside of my system at all times. So it's a neat little way to use the interface with the crafting card. You can also keep a certain amount of stocked items in your interface at all times and have them pulled out with a pipe or some other machine. And the last place you can put the crafting card is inside of a level emitter. And once you put the card inside of here, you're going to get a couple different options. First of all, it's going to gray out all this with the exception of this block here, which is going to be the target block. Then it's going to say you can either emit a redstone signal while the item is crafting or emit redstone to craft item, which I still don't know what does. So in this example here, I have this set to furnaces. So if I go ahead and pull 5 of my stocked items out of here, when it's crafting furnaces, it's just going to go ahead and light up. And when it's done crafting, the level emitter is just going to turn off. So this setup is a little bit more advanced. What I have here is I have a pattern provider set to make 1 reinforced alloy with 1 infused alloy, right? So I know how to make that item there. But I also need diamond dust or liquefacted diamond, liquefied, whatever, inside of this infuser. And I want to keep this full at all times. I don't just want to have my diamonds constantly exporting to make a ton of diamond dust. So what I'm doing is I'm saying I want to export this with a crafting card in here. So another use for the crafting card. And I want to automatically craft diamond dust whenever I can fit more inside the system. So you can see that I'm back full again, right? So if I go ahead and suggest that I craft some more reinforced alloy, I'll make 10 of those, okay? It's gonna go out in here, and then as this depletes, this machine over here, which has been programmed to know how to make diamond dust, is automatically going to get requested from this export bus over here, and it's going to crush diamond as needed in this machine and put it out in here. Now, I've been having a little bit of trouble on my tutorial world with lag here, and I'm pretty sure that these crafting cards, when they're constantly ticking to try to export something, will cause some lag. So I'm not really sure how much you want to use these while you're on your server. I can't like 100% confirm that, but just based on the problems I've been having right now in a single player world with a lot of machines in it, this probably isn't the best way to go, but you might definitely need this for a few different setups. And last but not least, the smithing table and stone cutting table patterns. Now basically this is super simple. You do not need a smithing table and you do not need a stone cutting machine thing here. All you need to do is click this, put your pattern inside of here, program it, and the molecular assembler will know how to make it. So for this example, I've taught my machines to make fire ingots with fiery blood and iron ingots programmed just like this. And I can go ahead and request a craft just like this, and it's going to make fire ingots just like it was using a smithing table. So yeah, pretty easy. You can also use the stone cutting mode here, and if you put a piece of, let's say, white concrete in here, you have a bunch of different patterns to pick from. Simply pick the pattern that you want, encode it, put it inside a pattern provider, and you'll be able to make anything like that. And that's going to do it for this episode. Don't forget to make your stuff look really cool so you can show your mom how awesome you are. Don't forget to like, subscribe, and stay poised for more awesome videos.